Logic 0, example 29.3, a conditional proof in natural English. So this is an example of something that we've all sort of seen in going to college, is that we have certain requirements for a degree, and they're often laid out in this sort of way. This is an example from the 2020 to 2021 course catalog at Cerritos College. And for the Philosophy Associate in Arts degree. So you have this required core. You got to select two from the required core, two of these courses, Philosophy 100, Philosophy 106, or Philosophy 160. And then you're going to select one from list A, Philosophy 130, Philosophy 140, Philosophy 201, or maybe one of those that you haven't already used from the core requirement. And then we have list B and list C. But we just want to focus on list A and consider this argument. From this breakdown of the major, we could say that if you have passed Philosophy 130, History of Ancient Philosophy, then you have fulfilled the requirement from list A, right? It says select one. And Philosophy 130 is on this list. So if you've done 130, then you've fulfilled the requirement for list A. That's our premise in this argument. And then we have the therefore. So here's the logical inference. Therefore, if you have passed both Philosophy 130 and Philosophy 201, contemporary philosophy, then you have fulfilled the requirement from list A. And of course, Philosophy 201 is one of these. It says only select one, but if you've done both, then you've fulfilled the requirement. That's the essence of the argument. Now, if somebody wasn't quite sure, wait a minute, that doesn't quite sound right. It says one and you're doing two. We could get a little more explicit and make an argument like this, and in the right sort of crowd, the right sort of social milieu, if you're hanging out with mathematicians or biologists, you know, people who rely on logic as a matter of practice, and you all sort of agree on that, you could lay out an argument like this in English. Assume as our premise that if you have passed Philosophy 130, then you have fulfilled the requirement from list A. That's just what the requirements say. And now suppose that you have passed Philosophy 130 and Philosophy 201. Since you have passed both classes, you have passed the first, right? Thus, by modus ponens, you have fulfilled the requirement for list A. Therefore, if you have passed both classes, then you have fulfilled the requirement. And that kind of lays things out a little more clearly and gives a proof of this inference from one premise directly to the conclusion. It fills in some of those logical gaps and hopefully would be convincing to your audience. This is all done in English. You know, we're not using symbols. And this is something that human beings are naturally inclined to do. As human beings, we like to talk. And one of the ways in which we talk is to produce logical arguments. Now, sometimes our logic goes wrong, or we don't feel inclined to do logic, but this is something that is quite natural to human beings. And it's just a matter of our facility with language. But our symbolic apparatus is a way of making the logical structure and logical inferences more explicit and perhaps a little more precise once we understand how the symbolic apparatus works. And this natural English argument maps directly onto the structure of the argument from the previous example. So if we go back to the previous example and we look at this proof here, this natural English argument has this form. This natural English proof has the form of this proof below. And we make the connection there by using these variable assignments. Okay, so we're gonna say let A equal you have passed philosophy 130, let B equal you have fulfilled the requirement from list A, and let C be you have passed philosophy 201. You have passed philosophy 130, that's A. You have fulfilled the requirement from list A, that's B. And you have passed philosophy 201, that's C. So let's take this first sentence and let's put it right into this structure here. So this is the premise. If you have passed 130, then you have fulfilled the requirement. And then we have this next sentence. Now suppose that you have passed 130 and 201. All right. So this is our supposition. Now suppose. And then we get this little logical inference. Since you have passed both classes, both A and C, then you have passed the first, A. And we know from our work with these formal proofs that that's the rule of simplification. But even if somebody didn't know the rule of simplification, they could follow the logic of what you're saying, you know, if they were a person that were inclined to follow logical arguments, which many of us are. And then we get this inference of modus ponens. Thus, by modus ponens, you have fulfilled the requirement from list A. Because we have this premise. If you do 130, then you've fulfilled the requirement. If you do both, then you've done the first. And since you've done the first, you have fulfilled the requirement. Okay. And then finally, we get to our conclusion. Therefore, if you pass both, then you have fulfilled the requirement. So the symbols simply show in a more formally, in a more constrained way, the structure of this argument, but within the right circumstances, that natural argument would be plenty enough proof, no need for the symbols. And the symbols are just bringing out what we naturally do, and sometimes we even naturally do without thinking that much.